Welcome to Ms. Smith's Math Tutorials. I'm Ms. Smith. In this final video on systems of equations, we're going to be talking about elimination. So this is the third and final way that we solve systems of equations. So in my first video, we talked about graphing. My second video, we talked about substitution. This one is elimination. This one's probably my favorite, almost a shortcut way to solve some of these. Your ideal situation for solving through elimination is going to be when you see that your equations are in standard form, which means you've got your x's, then your y's, and then your equals, your constants. Okay, so standard form. That's going to be the ideal situation to use elimination. To do elimination, there's kind of a phrase that we look for. So that phrase is going to be same but opposites. So that means we're looking for, once we've got our x's stacked up, y's stacked up, constants stacked up, we are looking for either x's or y's that are the same, meaning they have the same coefficient, the same number, but we want the numbers to have opposite signs. So looking at my x's, they're the same number. Both these x's have an understood 1 in front of it, but they're both positive. So that's not what I'm looking for here. My y's, so they both have a coefficient of 1, so same number, and they both have opposite signs. So this one's negative and this one's positive. This is what I call a perfect elimination situation. So once you found your same but opposites, you want to box them and cross them out. So that means that we are eliminating that, aka the elimination strategy, because they are the same but opposites. So with what we have left, so in this case I've got a positive 1x and a positive 1x, we add together. So 1x plus 1x is 2x equals negative 6 plus 8, which is going to give us 2, positive 2. So our last step to get x alone will be to divide out that 2, and we get x equals positive 1. So our same goal, and I should have mentioned this, and the same thing with our other strategies of solving systems of elimination, the goal remains the same. The goal is to find our x, y intersect. So in this case, we found our x is 1. So I still need to find my y. So this is where a little bit of substitution comes in, but we'll need to take this x, and I need to plug it in either here or here. So we're going back to our two original equations, here or here, and solve for y. So looking at these two, I'm going to pick this second equation because that top one has the negative y. I'd rather not deal with the negative if I don't have to. So I'm going to sub in that x right there, 4x. Let's write that out. So you'll notice, and I'm not highlighting in blue this video because I don't want you to confuse it with the substitution strategy, but there is a little bit of substituting in here. So we've just subbed in that 1 for x. It's completely replaced the x. So it doesn't be part of the x, it is the x. So 1 plus y equals 8. Now it's just an algebra problem that I solve, so I want to subtract 1 from both sides, and I get y equals 7. So there's part 2 of my answer. What is y? Y is 7. Now, you'll notice in this next example, we've got each of our equations are in standard form. My x's are on top, and then my y's right next to them, and then my constants. So this is an ideal situation to do elimination. Again, I want to look for same but opposites. So looking here, my x's are not, they are the same, but they're not opposites, they're both positive. Looking here, not the same, and also not opposites. They're both positive. We do not care about the constants. I'm solely targeting the x's and the y's. Okay, so don't worry about your constants. We're just looking here. So I don't have same but opposites. So I need to create a situation where I do have the same but opposites. In this case, you want to go with the easiest way to do it. I see that these x's both are the same, so I'm one step there. They're just not opposites. So I need to make one of these x's negative so that I can create an elimination situation. So I can do that. Let's say I want to make this top one negative, and it does not matter if you'd like to do this to the bottom instead, you can. It's just personal preference. So I'm just going to go with the top. If I multiply this entire top by -1, that will make this x negative, and by default it's going to make everything else negative too. So you just have to be careful and make sure you distribute this -1 throughout the whole equation. So I'm distributing it not only there, but there, and there. So -1 times x is -x. -1 times 2y is -2y. And -1 times 6 is going to be -6. Okay, so you'll notice I made everything negative. Now this bottom equation, I want to keep that the exact same because that one already has a positive x. So I'm not going to multiply anything against the bottom because it's already exactly as I need it to be. So you'll notice now I have the same but opposites. I've created an elimination situation. So I'm going to do the same step from here on out that I did with the other problem. So I want to add what I have left. So -2y plus 3y. That just gives me 1y equals -6 plus 9. That's going to give me +3. So I have found part of my answer. So I'm going to come up here. This is where I'm going to list my intersecting point, my answer. My y is 3. So that's part of my answer. I'm going to need to use a little bit of substitution to figure out what my x is. If I know that my y is 3, I can take that 3 and I can sub it in here. I can sub it in here. Or technically, you could also sub it in here. You could also do here, and you'll notice those two are the exact same. So you can sub that y into any of these 4 equations. Now, the trick is that it's always going to be best to sub it into one of these 2 equations. Here, it doesn't quite make as much of a difference other than we're dealing with negatives, but it will make a bigger difference in some later problems that we'll see. So you always want to stick to one of these 2. I'm going to go with this top equation just because I see my numbers are a little lower. So I'm going to take this 3 and I'm going to sub it in for that y. So I'm going to rewrite that down here. I'm writing this original equation. I do not need to write the -1 parentheses, just the original equation. So x plus 2 times y, which is now 3, equals 6. So now I can solve for x. 2 times 3 is 6. I want to get my x alone, so I'm going to subtract 6 from all sides, and I get x equals 0. So my x is 0. There's my part 2 of my answer. Let's look at 2 more examples. So for number 3, we again want to be looking for the same but opposites. This is an ideal situation for elimination because I've got both equations are in standard form. Same but opposites. Well, I don't have any here. And so then I would look for a situation like we had on number 2 where I could just multiply a -1. So maybe if I had 2 that were just the same but not opposite signs, and I don't have that here either. I'm going to have to do something a little different. Now there's a couple ways you could go about this. I'm going to show you the easiest way, if you notice, I'm going to target this center area, so my y's. That's what I'm going to work on. I want to create a situation over here where I've got the same but opposite signs. So you'll notice that 7 times 2 would give me 14. These two are already opposite signs, so I don't need to worry about changing the sign, only changing the number. So if I did 7 times 2, that would give me 14. So what I can do is multiply this entire bottom by positive 2. Now that's not only going to change a 7, but it's going to change every single part of this. I don't want to change the top at all. So I'm not going to multiply anything by the top. I want to keep that exactly as it is. So I'm just going to rewrite it. 5x minus 14y equals 22. The bottom, I want to see some changes. So I need to distribute this 2 to every part of the problem. 2 times negative 6x will give me negative 12x. 2 times 7y is going to give me positive 14y. That's what I want. I want the same but opposite. So let's keep going. 2 times positive 3 will give me positive 6. Okay, so this is what I wanted to create, a situation where I have the same but opposites and what I like to call an elimination situation. I want to take what I have left and add it together. So 5x minus 12x, so it's the same thing as saying 5x plus negative 12x. I'm just shortening it. Yeah, negative 7. All right, equals 22 plus 6, which is going to give me 28. Notice I'm just going with whatever sign is in front of here, so positive 22 plus 6. So now I want to get my x alone, so I want to divide out that negative 7, and I end up with x equals negative 4. Okay, so that's part of my answer, so I'm going to come over here. This is going to be my xy answer right here. I found part 1 of my answer. X is negative 4. I still need to find part 2. My y. So I can take that x equals negative 4, and I could plug that in for x. I could do it here, here. Technically you could do it here, even though these two are the same, or here. But like I said in the other problem, your best interest is going to be to pick one of these two original equations. They're going to have the lowest numbers. So I'm going to go with this bottom equation simply because that one's got that 14 and the 22, so you can go with the top equation. You should get the same answer. I'm going to go with the bottom, just personal preference. So if I know x equals negative 4, I can plug that in for x. So let's rewrite that. Again, I'm not doing this 2 times the equation. That was to create an elimination situation. I'm now going with the original equation. So negative 6 times x. So now it's just solving for y. Negative 6 times negative 4 would be positive 24. Bring down my 7y equals 3. I want to subtract 24 from both sides. And I would get 7y equals negative 21. Divide out my 7. And I should get y equals negative 3. So there's part 2 of my answer. I found my y. It is negative 3. This next example, something interesting happens. Let's take a look at this. I want to look for the same but opposites, just like I have on all my elimination problems. I don't have it here, and I don't have it here. Not only that, but it was kind of nice here because I recognized 7 times 2 would give me positive 14, which would create an opposite situation. There's nothing I can multiply 2 by to get 5, and there's nothing I can multiply 2 by to get 7. What I'm going to have to do, I call this a crisscross situation. I've got to either target my x's or target my y's. In this case, because my x's have a little lower number, that 5 instead of that -7, I'm going to target my x's. You can do the y's, and that's fine, but I need to figure out what would be the next best thing I could multiply 2 by to give me a number and 5 by to give me a number that would create an elimination situation. So I know that 2 times 5 would give me 10. So what I'm going to do is bring my 2 up here and bring my 5 down here. And I want to make a situation where they're opposite signs. So in this case, if I multiplied this out, they would both be positive 10. So I need to make one of them negative. I'm just going to make the 2 negative. You could do the 5. It doesn't matter. But I'm just going to go ahead and make the 2 negative. So let's multiply out this whole top, and then we'll do the whole bottom. So -2 times 5x would be -10x. -2 times -7y is going to give me positive 14y. -2 times -28 is going to give me positive 56. And now let me come down here and I'm going to distribute the 5 out throughout this whole equation. So 5 times 2x will give me positive 10x. That's what I want, the same but opposites. 5 times -2y will give me -10y. And 5 times -12 is going to give me -60. So now I've created an elimination situation right here, the same but opposite signs. And I'm going to add together the rest of what I've got. So 14y minus 10y, that would give me just 4y. 56 minus 60 is going to give me -4. So I'm going to divide out my positive 4. And I get y equals -1. So there's part 1 of my answer, which I'm going to list just right up there. Y equals -1. So I still need to find the next part of my answer. I need to figure out what x is. So I can take this newfound information that y equals -1, and I can plug that -1 in here, here, technically here or here, but we're going to go with these because they're lower numbers. And again, it doesn't matter which one you choose. I'm going to go with the bottom one just because I see the numbers are a little lower. So I'm going to sub in that -1 right there for y. So let me rewrite that bottom equation. -2 times -1 would be positive 2. Alright, I want to get my x alone, so I'm going to subtract 2 from both sides. 2x equals -12 minus 2, that would give me -14. Divide out the 2, and x is -7. So there's the next part of my answer. What is x? It is -7. Just like in the last 2 videos, I showed you 2 special cases, and I'm going to do the same thing of how we would identify a special case when given elimination, when using the elimination strategy. So let's look at number 5. As we know, we want to look for the same but opposites. I don't have that here, and I don't have that here, so I know I'm going to need to do some multiplying. I see it, and here you can target the x or the y, it doesn't matter, but I'm going to target the x's. So I noticed that these are already opposite signs, so that's good. I don't want to adjust the signs at all. And I noticed that 4 is half of 8, so 4 times 2 would give me a -8. And if I just bring this 8 over, it'll be positive 8. So that would be a perfect elimination situation. So I'm going to multiply this whole top by positive 2. So let's go ahead and distribute that 2. So 2 times negative 4x, that would give me negative 8x. 2 times negative 8y would give me negative 16y. And 2 times 8 would give me positive 16. Now I want to bring over this bottom equation. I don't want to multiply anything times the bottom because I already had my sign and number exactly as I wanted it. So we targeted my x's, and I now have a perfect elimination situation with my x's. I'm going to add together everything else. Negative 16y plus 16y. So you'll notice that actually that cancels out to 0. Bring down my equal sign. 16 minus 16. Well, that also eliminates to 0. So now we're in a situation where we've got 0 equals 0. So you would ask yourself, does 0 equal 0? Is that a true statement? And it is. So in this case, it would be an infinite solutions. We got a true statement, so there would be, if I were to graph these two lines, which I could do, I'd have to do some rearranging, but I could graph them. And if I did, these two lines would overlay each other. They would be the exact same line. Let's move on to number 6. Let's see what happens here. So I want to look for the same but opposites. And I don't have that here with either my x's or my y's. In this case, I'm going to target my y's because I noticed that even though they're both the same sign, 3 times 2 would give me 6. So I can easily just multiply this whole top by 2, and that's going to give me, it's actually going to give me a negative 6. So I've got to change my sign as well. I'm going to multiply by a negative 2. Because I want to end up with a positive 6 and a negative 6. So I'll have an elimination situation. This elimination really requires, and you've probably figured this out by now, but it really requires thinking ahead to what's coming. It's something you got to practice to get the hang of. But anyway, let's go ahead and distribute this 2. So negative 2 times negative 5x, that's going to give me positive 10x. Negative 2 times negative 3y, that's going to give me positive 6y. And negative 2 times negative 19, that's going to give me positive 38. I'm going to bring my bottom equation over. I didn't want to change anything in that at all because I was already set up perfectly. Okay, so remember we targeted my y's so that we could have a perfect elimination situation, two with the same but opposites. So we want to add together everything else. Now you might be noticing, oh, we got the same but opposites there as well. Let's go ahead and just add together what we have left. So 10x minus 10x is 0. Those two cancel as well. And 38 minus 28, that's going to give me 10. So you've got to ask yourself, does 0 equal 10? Is that a true statement? It's not. That's a false statement. So therefore, this is a no solution. Or if you just want to write NS, no solution. So if I were to graph these two lines, which I could do, they would be parallel. So these two lines would never intersect with each other. This has been Ms. Smith's Math Tutorials.